Hello everyone, I'm Frank and welcome to Frank Puzzles. And this is today's easy level puzzle. And take that easiness with a grain of salt because it's considered easy by the people on the Logic Masters Germany forum. And there's a lot of really smart people there. Today's puzzle is called Counting Whispers by Mimic. And here are the rules. We have normal Sudoku rules apply, which means in every cell in the grid, place a single digit such that every row, column, and designated 9-cell region contains the digits 1 through 9 exactly once each. A green circle, two cells connected by a green German whisper line must have a difference of at least 5. And I call these lines Whisper 5 lines because the setter came up with that name, and I thought that made a lot of sense because it's very easily extendable. So as an example, if we have a 3 here, then this would have to be an 8 or a 9 next to it on the Whisper 5 line, / German Whisper line, because the only digits which are 5 or more away from 3 are 8 and 9. And that's an example of how Whisper 5 lines work. Also, a green circle indicates exactly how many circles contain that digit. For example, if there is a 4 in any circle, then exactly 4 circles contain a 4. So say we had a 4 here. There would have to be four fours in total in white circles. Or in circles, I should say. So you could have 4 here, 4 here, and 4 here, and that would satisfy the circles having a 4 in 4 of those circles. And those are all the rules. If you like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay. How many circles do we have? We have 1, 2, 3, 4, 5, 6, 7, 8. Sorry, 1, 2, 3, 4, 5, 6, 7, 8, 9, 12, 13, 14, 15, 16, 17. So we have 17. 1, 2, 3, 4, 7, 9, 11, 13, 15, 17. So that means the digits in the circles must sum, the unique digits in the circles must sum to 17, right? Because they appear however many digits they are. So 1 would appear once, 2 would appear twice, 3 would appear 3 times, and 4 would appear 4 times. Well, the interesting thing about that, though, is 1, 2, 3, 4 can add up to at most 10. So we're going to have a digit that is a high digit. So 17. It could be 1, 2, 4, 9. We have at least 3 unique digits because we have 3 digits in a row here, which are the same. Or, sorry, in the same row. Adding up to 17. You could have something like 6, 9, and 2. So you could potentially have 3 unique digits. Let's mark same sets. I don't know how we mark them, though. Green, these are the same sets here. And this was obviously different. This is different from that, which is different from that. This is because you on a Whisper 5 line, you'll always alternate between low and high digits. The low digits being 1 through 4, the high digits being 6 through 9. And if you want to understand why, you can go to one of my Learn How to Sudoku puzzles with a Whisper 5 line in it, and I'll explain why that is the case. So these two are the same set, and this is a different set. This is a different set. We have these two being the same set, and this is a different set. These two are the same set, and this is a different set. So this is different, same, different, right? So that's the different set. 1, 2, 3, 4. So these are different sets. We have at least 1, 2, 3, 4. So in these Whisper 5 lines, we have one here that's different, one here that's different, one here that's different, one here that's different. And then these are different. So that's guaranteed. You have to have 5 of one set. Okay. Um. Hmm. So we have to have 5 that are at least the low. We have to have at least 5 hellos and at least 5 highs. The other sets, assuming that these are the same sets here, that's not a safe assumption though. Okay. What are possibilities? So none of these digits see each other. They're not in the same row or column or box as each other. None of these can be a 4. But they could be 3s. Or these two can't be a 4. This one could. Oh, that's interesting. Huh, okay. So one thing is, for each of these other sets, there has to be 2 distinct digits for them, right? Here we have 2 distinct digits, they're in the same row. Here we have 2 distinct digits, they're in the same box. Here we have 2 distinct digits, they're in the same row. This one does not, so it could be the same one. So the question is, though, you have 2 distinct digits. Can you have 2 distinct digits as high digits? 6, 7 could be with 1 and 3. That adds up to 17. 6, 8 would have to be. So you could always have 3 digits, right? Which are the same. Um. Okay, so where are the yellow sets? They have to be here. Pink is here. This is gray. We have dark, dark, and dark. Green, green, and green there. Blue and blue here, and these are orange and orange. Okay. These are others. So red, we're just going to be using as the opposite of the main one. Okay. So these are 2 pairs. these are opposite pairs. These are opposite. These have, so one of these has to be yellow and the other one is a 5. So we have yellow or 5 here, and this is 5 or yellow here. Okay. This has 2 of each here. And 1 of each there. We have 2 of each here. So you could always have 2 highs and 1 low as any combination. 4 would require a 9 to be with it. So you would have to add up to 17. Oh, you can never have 5 be part of any of these circles. So 4 and 9 does not work. So if you have 2 high digits, cannot be 4 and 9 together. In these circles, I should say. If you have 2 high digits in these circles, cannot be 9. The low digit cannot be 4, I should say. For just the low digits, you can't have 3. And the problem is you need 5 lows and 5 highs. So assuming, oh, you can't have 3 lows. So can you ever have 2 highs? You have to have 3 unique digits for lows. And that's not going to work. Right? So even if you have 6 and 7, that's 13. 17 minus 13 means you have 4 low digits. But because of the way that we count these circles, even if you have the minimum amount for all the circles, you have to have 5 lows. And yeah, same for highs. You have to have 5 highs. So that means you cannot ever have 2 of the same set that are high. So therefore, pink must be low. So this must be low, which means these are high. Yellows must be low, which means this is high. And medium grays must be low, which means these are high. That's kind of coincidental. Okay, so let's remove this. So this is blue or red here. We have 1 each here. So this is dark. We'll make these medium. We don't know that this is red. We'll make that yellow with it. And I don't... maybe I should change this from blue. We'll make that, I don't know, I guess light. Maybe we should make these yellow. And we'll make these light. So these are yellow. Okay, so we know these are guaranteed to be low and high, and this must be the same high digit. It's always in between 2 unique digits. How many lows do we have then? We have a guaranteed 1, 2, 3, 4, 5, 6, 7 lows, and one of these is going to be low, so guaranteed 8. That means you're going to have a 4. If you don't have a 4, 1, 2, 3 by themselves only add up to 6. So 4 is going to have to be in these circles 4 times. Oh, we have 9. So we have guaranteed 2, 3, and 4 at least on the lows, right? Because we have 1. So these, you can't have 2 highs. you have to have the same one being low. So sorry, you have to have the same high being the high. So you're guaranteed low here, low here. 1, 2, 3, 4, 5, 6, 7. One out of these, 8, and one out of these, 9. So you're guaranteed 2, 3, and 4 are at least in the circles. You have guaranteed. That means 2, 3, 4 are in the low circles. So it must be, it's either 1, 2, 3, 4, 8. Sorry, 1, 2, 3, 4, 7, or 2, 3, 4, 8 are in the circles. So the high digits is either 7 or 8. We're not sure which. We can mark that as these are the same digit. So it must be 7 or 8. So the digits next to A cannot be 4. So that means these are 1 through 3 here. 1 through 3. This is 1 through 3. Okay. So here, one of these digits is going to have to be 6 or 7, right? So we have either 1, 2, 3, 4, and 7. Interesting. If this is 7, this would have to be 1 and 2 to be next to it. So if this is 7, this would be 1 and 2, which means 1 cannot appear in any of the other circles. Because the 1 would be guaranteed to be one of these two. So 1 can never appear in the rest of the circles, period, because if this is 8, 8 has to be next to 2, 3, and 4 only. So none of these digits can be 1 as lows. So this is 2, 3, 4. We have 2, 3, 4. This is also 2, 3, or 4. This is also 2, 3, or 4. Okay. This digit is next to 3 unique digits that are high on the Whisper 5 line, so this is 1 or 2 there. This has to be, so these digits have to be 7, 8, or 9 to be next to a 2, 3, 4 guarantee. This digit has to be 8 or 9 here to be next to 2 and 3 or 2, 3, and 4 here. Okay. Okay, so now we have a guaranteed in these digits. We have 9 lows in all of these Whisper 5 lines here. That means this can't be, green cannot be 2 lows here. If this were 2 lows, the problem is then that would be 11 lows across all the circles, which obviously 1, 2, 3, 4 can't add up to. That adds up to only 10. So the green here has to be high. So these are high and the lights are low. And this must be A again. So those are both A, which means these cannot be high, because if these were high, the problem is they would be the same digit as A. So the dark has to be low, the mediums have to be high, and we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Wait, no. 1, 2, 3, 4, 5, 6, 7, 8, 9, and one of these is low as a 10. So therefore, we have 1 through 4, and A has to be 7. So A is 7. So we have 7 here, which can only be next to 1 and 2 on the Whisper 5 line. So this can't be 3, it's 2 there. We have guaranteed 2's already accounted for in all the circles. We have 2 here, and we have a 1 here. That means this cannot be 1 or 2. This can't be 1 or 2. This can't be 1 or 2. So we have 3, 4, 5 here. 3, 4, 5 here. 2 is here. 7 can only be next to 1 or 2 here. This is 7 here, which can only be next to 1 or 2. These are 3, 4 pair here. Or not pair. They can only be 3 or 4 here. So one of these is 3, one of these is 4. One of these is 3, one of these is 4. One of these is 3, one of these is 4, which means 3 is already accounted for in all the circles. One of these is 3, one of these 2 is 3, and one of these 2 is 3. Therefore, we have to have a 4 in one of these spots. So either 4 is here or 4 is here, which means 9 is one of those 2. Because 4 can only be next to 9 on the Whisper 5 lines. If 4 is here, that means this is 3. If this is 4, that means this is 3. That doesn't really tell us much. Anyways. So 7 is one. So this is a 4-7 pair here. So we have one of these is 4, the other one is 7. We have 1, 2, 3, 4, 5, 6 7s, and then one of these is 7. The other one's 4. So that means if this is 7, this is 1, 2. So this could be 1, 2, or 9, and this is 1, 2, or 9 for the same reasoning. We have a guaranteed 9 there. If this is low, it cannot be 1, 2. This is a high, it has to be 8 or 9. That means we have an 8, 9 pair in column 3, which eliminates 8 and 9 in the rest of the column. So no 8 or 9 here. Can't be 7 because of 7 in the column. So this is 6, which can only be next to a 1 on a Whisper 5 line. 1 eliminates 1 here, so that's 2, which can only be next to 7, 8, or 9 on a Whisper 5 line. So these are 8 and 9 pairs. We have 1 there, 7 there. That means we have to have 3, 4, or 5 here. Interesting. Okay. 7 has to be one of these 2 digits here. 7 can't be... This digit has to be 8 or 9 to be next to 3 or 4. We have a 1, 2, 1, 2 pair in row 3, interestingly enough, which eliminates 1, 2 in the rest of the row. This could be 6, no 7, 8, or 9 is a possibility. We have a 3, 4 pair here. That eliminates 3, 4 in the rest of the box. So one of these is going to have to be 3 or 4. This can't be 6 or 7. This is 8 or 9. This can't be 1 or 2. Actually, so this has to be the other 3, 4. So we have a 3, 4 pair now remaining in row 1, which eliminates 3, 4 in the rest of the row. So now we have, what, 5, 6, 8, and 9. 6 can't be here because of 6 in the box. So we have to have 6 be one of these 2 digits there. This can't be 1, 2, or 7, so it could be either 3, 4 if it's low, or if it's high, it could be 6, 8, or 9. Still pretty broad. Okay. This has to be next to 7 and or 8, but it cannot be 3 or 4 because of the 3, 4 pair in the box, so this is 1, 2. We have a 1, 2 pair now in column 4. That's interesting. Remaining digits of row 3, we have 3, 4, 5, 6, 8, and 9. What else do we have? We have a 3, 4 pair in row 4, which eliminates 3 and 4 in the rest of the row. And this can't be 1, 2, or 7 because of the 1, 2, 7 triplet in the box, so that leaves us as 5, 6, 8, and 9. We now have a 5, 6, 8, 9 quadruplet in row 4, which eliminates 5, 6, 8, and 9 in the rest of the row. So this has to be 1 and 2. This must be 1 or 2, and those are both lows. Now we have a 1, 2, 9. Okay, this can't be 9 because of one of these is guaranteed to be 9. But we have a 1, 2, 9 triplet in column 9, which eliminates 1, 2, 9 in the rest of the column. So this can't be 1, 2, or 9. This can't be 1 or 2. Where's the other 1 or 2 in box 3? It has to be there. So this is guaranteed to be 1 or 2. This can't be 1, 2, 3, or 4. So this must be 5, 6, 8, or 9. Again, no 6 here. This has to be 3 through 8. Don't know exactly which. So we have 1, 2, 1, 2, 1, 2. 9 of these can be 1 or 2. Remaining digits in row 5 are 3 through 3, 4, 5, 6, 8, and 9. Okay. Okay. What else do we have? This is 1, so this can't be 1 here. It's 2. That eliminates 2 here, so that's 1, which eliminates 1 here, so that's 2. Okay. 2 in box 4 has to be one of these two. We have 8 and 9 there. That's fine. 1 cannot be... So we have in column 4, the remaining digits are 3 through 6, 8, and 9. Obviously no 6 here because of 6 in the row. 2 is obviously there. 1 then has to be one of these two because it can't be here because of 1 in the row. Remaining digits of box 1, we have 3, 4, 5, 8, 9. Okay. So 5 and 6 in row 4 have to be here. That eliminates 5 and 6 in the rest of the box. Oh, right. So in box 5, where are 3 and 4? They can't be here because of the 3, 4 pair in the row. So they have to be here, which eliminates 3 and 4 in the rest of the row here. This can't be 3 or 4. It's 5, which makes that pink. This can't be pink here. It's the other 3 or 4 here. That eliminates 3, 4 in the rest of the box. This can't be 5 because of 5 in the box. 3 and 4 eliminate 3 and 4 here. So that must be 7. So then the oranges are all high. And the yellows are all low. So this must be 4, which is next to 9. This can't be 9 here. This must be high, so it's 6 or 8. 4 eliminates 4 here, so that's 3, which makes this not 3, so that's 4. 4 can only be next to 9 on a Whisper 5 line, so this is 9. That makes that 3, which makes this 4 there. That's 3 in the corner. We celebrate because we're close to solving it. No more 3 or 4s allowed here, so it's 5, 6, 8, and 9, with a guaranteed 5 and 6 here. That eliminates 5 and 6 in the rest of the box. This can't be 9. None of these could be 9. So we have a 5, 6, 8 triplet now in row 3, which eliminates 5, 6, 8 in the rest of the row. No 8 here, it's 9. This can't be 8 because of the 5, 6, 8 triplet in the box, so this must be 1, 3, and 4. 9 eliminates 9 from being here. Okay. 4 eliminates 4 from being here. This can't be 4 or 3. No 9 here. We have a 5, 6, 8 triplet in column 9, which eliminates 5, 6, 8 in the rest of the column. So this can't be 5, 6, or 8. It's 7. That eliminates 7 here. So the last 7 has to be there. And that's 9 sevens. No more 9s here because this had to be 9 there. No more 9 here. Okay. 3 eliminates 3 here. 4 eliminates 4 here, so that's 3. Hmm. This is 3, 4, 8, and 9. 5 and 6 are here. No 4 here because of 4 in the column. This is 3, 4 as a pair. That eliminates 3, 4 in the rest of the box. So we have what? 1, 2, 5, 6, 8, and 9 left. No 2 here because of 2 in the row. No 2 here because of 2 in the column. Okay. We have a 1, 2 pair in box 6, so this can't be 1 or 2. So this is also 3, 4, 5, 6, 8, 9. No 4 here because of 4 in the column. 2 then has to be one of these two here for that to work. In column 7. 9 eliminates 9 here, so that's 8. 4 cannot be next to 8 on a Whisper 5 line. It's only 4 apart. So this is 3, this is 4. That makes this 9 to be next to it on the Whisper 5 line. 9 eliminates 9 here, so that's 8. 9 eliminates 9 here, so that's 8. No more 8 in the row then. No more 8 in the column. No more 8 in the box. This can't be 9 because of 9 in the row. 8 eliminates 8 here, so that's 6. 6 can only be next to 1 on a Whisper 5 line, so this is 1, which makes that 2. We have 3 3s already in circle, so this can't be 3. It's 4, which can only be next to 9 on a Whisper 5 line. That eliminates 9 here, so this is a 5, 6, 8 triplet. That eliminates 5, 6, and 8 in the rest of the box. So this becomes a 3, 4, 9 triplet, which eliminates 3, 4, and 9 in the rest of the row. So no 3 or 9 here, no 5 here because of 5 in the row. 6 eliminates 6 here, so that's 8. So the remaining digits now are 3 and 5 in box 6. That eliminates 3, 6, and 5 in the rest of the row. This is 4, 9 as a pair. We are remaining 2. This can't be 2 then, so that's 1. That means 2 has to be there. Remaining digit in box 4 is a 6. So that's 6 there. 6 can't be here because of 6 in the column now. So where's 6 in box 3? It has to be there. And I think the remaining digits are just from normal Sudoku. Yeah, they have to be. Okay. So, what are the remaining digits? 8 eliminates 8 here, so this is 5. This can't be 5 or 8. It's 9, which makes that 8. 8 eliminates 8 here, so it's 5 and 8. 9 eliminates 9 here, so it's 4 and 9. Okay. Ones. Do we have enough information about ones? Not really. Let's go through just the ones that we have filled out the most. Column 2, we have 3 and 6 remaining. This can't be 3 because of 3 in the row, so that's 6 and 3 there. Column 1, we have 1, 4, and 5. 4 cannot be either of these, so 4 has to be there. Therefore, this is a 1, 5 pair here. Okay. Row 7. Did I say row for these? I meant columns. Okay. Row 7, we have 1, 2, and 5 remaining. This can't be 1 because of 1 in the column. This can't be 2 because of 2 in the column. And then we need to fill out these. Column 7. We have 2, 3, 5, and 6 here. No 3 here, no 2 there. Column 8. We have 1, 3, 5, and 8 here. 8 cannot be here because of 8 in the row, so where is the 8 in column 8? It must be here. Okay. Hmm. 3 is one of these two. Hmm. So again, the sevens appear in seven circles. 1, 2, 3, 4, 5, 6, 7. Threes appear in three circles. 1, 2, 3. 4 should appear in four circles. It does. And 1 appears once. 2 appears twice. That's fine. These two are the same digit, but that doesn't help us any. Hmm. We have a 5, 6 pair in column 5, which eliminates 5 and 6 in the rest of the column. No 5, 6 here, it's 1. No 5, 6, or 1 here, it's 9. That means this can't be 9 and this can't be 1. 1 eliminates 1 here, so the A's are both 2. So these are 2. That eliminates 2 here, so it's 5 and 1. That means where's a 2 here? It has to be there. 1, this is 3, 4 as a pair, which eliminates 3, 4 in the rest of the box, so that's 1. This is 3, 4 as a pair, which eliminates 3, 4 in the rest of the box, so that's 9. No 9 here, no 1 or 2 here, it's 5, 6 as a pair, but 1 eliminates 1 here, so it's 5 and 1. 5 eliminates 5 here, so it's 6 and 5. 2 eliminates 2 there, so that's 1. No 1 or 5 here, it's 3. No 3 or 5 here, it's 6. 3 eliminates 3 here, so it's 5 and 3. 6 eliminates 6 here, so that's 8. No 6 or 8 here, it's 5. 3 eliminates 3 here, so it's 4 and 3. Which eliminates 3 there, so it's 4 and 3. 5 eliminates 5 here, 6. No 5 or 6 here, it's 8. That leaves this as a 6 and this as a 5. Well, uh-oh. That should have solved. 1, 2, 3, 4, 5, 6, 7, 8, 9. 2, 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. 4s, 5s, 1, 2, 3, 4, 5, 6, 7, 8, 9. 6s, 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. 8s, 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4. Okay, so why didn't it solve? Did I mess something up? I might have. 1 through 9 here. 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 Through 9 there. 1 through 9 there. 1 through 9 here. 1 through 9 here. One, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4. 1, 2, 3. 1, 2, and 1. I'm confused now. This looks like it works. 3 is 5 away from 8. 8 is 5 away from 2 and 3. 2 is 5 away from 7s and 8s. 6 is 5 away from 1, which is 6 away from 7, which is 5 away from 2, which is 5 away from 7 away from 9, which is 5 away from 4. 7 and 8 are more than 5 away from 1. 1 is 8 away from 9. 4, 9, 3. 3 and 8 are 5 away. 8 and 1. 1, 7, 7, 2. 6, 1 is 5 away. 1, 7 is 6 away. 1, 9 is 8 away. 9, 4 works. 3, 8. 8, 2. 2, 7, all 5 away. 7, 2. 2, 8. 2, 9. 9, 4 all work. What's going on? I'm pretty sure this is the solution. Why didn't it resolve? 1, 1, 1. Okay, let's remove the coloring so that we can actually see these. Oops. ones. 1 in row 1, 2, 3, 4, 5, 6, 7, 8, 9. Column 1, 2, 3, 4, 5, 6, 7, 8, 9. Box 1, 2, 3, 4, 5, 6, 7, 8, 9. 2, row 1, 2, 3, 4, 5, 6, 7, 8, 9. Column 1, 2, 3, 4, 5, 6, 7, 8, 9. And threes, and then boxes. 1, 2, 3, 4, 5, 6, 7, 8, 9. Box 1, 2, 3, 4, 5, 6, 7, 8, 9. Row 1, 2, 3, 4, 5, 6, 7, 8, 9. Column 1, 2, 3. Oh. How did I mess this up? How did I get? That's weird. Okay. I don't know what. Yeah, so that's fine. Okay, so that's 3. How did I mess this up? That's weird. Okay. 4 eliminates 4 here, right? So 3 and 4, which eliminates 4 here, so it's 3 and 4. How did I mess that up? I don't even know. Anyways, 8, that's 5, 6, 5, 8, and 6. And then this is 6 and 3, which makes us 5 and 3 there. I don't know how I messed that up. That was weird. Yeah, I don't. That was weird. I guess I just put that 3 and then put that also 3. Ugh. Sometimes you do that. Well, aside from that little bobble, fairly straightforward. Yeah, I don't know. I just made a stupid error there. So, execution-wise, it seems easy level. Logic-wise, seemed easy. Pretty easy. Maybe a touch more difficult than easy, but I don't think it's quite challenging level. Anyways, I hope you enjoyed that solve, even with me mixing up the 4s and 3s here. That was weird. And I'll see you next time on Frank Puzzles. Take care.